Hey, welcome to Algebra 2 and Precalculus, your first set of notes for the year. So yes, Algebra 2, Chapter 2 is the same, at least the first couple of sections, is the same as Precalculus, Chapter 1. Okay? So we're going to start by talking about a relation. So a relation pairs one type of information to another, but a function is a special kind of relation in which each value of the x, or the input, is paired with exactly one value of the y, which is the output. Okay, so with a function, you have this value that's going in, and it can only give you one value coming out. Okay? So if x is repeat, then it's not going to be a function unless it gives you the exact same y, which we don't really see that. So one other thing to remember is that x is always the independent variable. Okay, and y is always the dependent variable. Okay, so your y value, what you get out, depends on your x, which is what you put in. Okay, so let's look at this table. So the table below shows a relation where the carbohydrates are the input variable, or the x value, and the food type is the output variable, or the y value. Okay, so here we have our x's and our y's. Okay, so this is what's going in. So if Bob wants to know what he can eat that's 15 grams of carbohydrates, he'll put 15 in, and out will come a list of things he can eat. So in that table with 15 grams of carbohydrates, you can have, so it's paired with 4 different foods. You could have bread, pasta, apple, or mashed potatoes. So does that represent a function? In other words, if we put one x value in, do we only get one y value? No, we do not. So this one is not a function. Okay, it does not represent a function. Okay, our reason would be 1x gives many or more than one y values. One way to say this is to say that x's repeat. So if we, look at this in a table like this one, you can see that the x repeats several different times. Okay, so let's look at this next table. It says a person who needs insulin knows that for every 15 grams of carbohydrates they eat, they're going to need 1 unit of insulin as shown in the table. So here's the table. Someone eats 15 grams of carbs, they need 1 unit of insulin. 20 grams, 1.5, 25 grams, 1.5, 30 grams is 2. So does this table represent a function? So for every one x value I put in, do I get one y value out? Yes, I do. It doesn't matter that these two y values are the same. The x values are different. That is what I'm looking for. Okay, so yes, this is a function. And our reason is x's do not repeat. Okay, or for every x, there's only one y. Okay, we have a couple more tables here to look at. So does this table represent a function? So let's start by looking at our x's. Do we have any x numbers that repeat? Nope. And do we have any x's that split off and go to 2 different values here? No. Okay. So in that case, this is a function. Okay. Because x's do not repeat. Or for every x value, there's exactly one y value. Okay, and the last table on this page, let's look at this one. So our x values are 0, 1, 2, 1, 4, 5. Does this table represent a function? Well, there's a 1 and there's a 1. They repeat and they do not go to the same y values. So no, this is not a function. And our reason is because our x's repeat. Okay. Okay, so let's take a look at the next part. So we're going to talk about how you represent functions. So we can represent functions using words. So we could say the number of units of insulin is a function of the number of grams of carbohydrates. In other words, the number of units of insulin depends on how many grams of carbohydrate someone eats. In other words, y, the dependent variable, is a function of x, the independent variable. So when we write this algebraically, we write it as y equals f, standing for function of x. Okay. So you don't have to use y, f, and x. You could say c equals gt, or you could say, you guys have seen several other ways that this has been done. So you could say p equals rt. So there's just all different letters you could use here. You just have to know where each of these parts is. So in c equals gt, the function name is always going to be what's with the independent variable. The independent variable is always going to be what's in parentheses, which is also what the variable in the equation is going to be. And the dependent variable is going to be on the other side of the equal sign. Okay, so if we're given a function here, f of x, so f of x, I'm going to write it over here actually, f of x equals 7x. And I'm asked for f of negative 6. So if I look from here to here, what's different? Well, that x, that independent variable, is replaced with a negative 6. What that means is anywhere in my equation, I'm going to replace that x with negative 6 or whatever's in those parentheses. Okay, so all that this means is, hey, this is the independent variable or the variable that's in our equation. Okay, and this right here is what I'm plugging in for it. Now remember that this whole piece right here is really your y, it's your output. We're just calling it f of x because we know that it's a function. It's got certain properties that make it a function. So if I'm given the function f of x equals 7x and asked for f of negative 6, this is the same as asking for the value of the function at x equals negative 6. In other words, I'm plugging that negative 6 in. So same thing, if I'm given the function g of x equals x minus 9 and asked for g of 8, this is the same as asking for the value of the function at x equals 8. So I'm just plugging that x. Instead of x, I'm plugging 8 in. Okay. And then the last one says, suppose you are given the function h of x equals negative 2x plus 3 and asked for h of 4. This is the same as asking for the value of the function at x equals 4. So now we're going to actually evaluate. What's another word for evaluate? Evaluate also means solve. So we're going to actually plug these values in and find an answer. So here it gives us f of x equals 10x minus 1. But it wants us to find f of negative 2. So a function of negative 2. So all we're going to do, anywhere we see an x in the equation, we're going to plug in that negative 2. Okay. So now I'm just going to do the work here. So 10 times negative 2 is negative 20 minus 1 gives me negative 21. Let's take a look at the next one. So g of x equals negative 5x plus 13. I want to find g of 1. So anywhere I see an x, I'm going to plug 1 in. So g of 1 is going to equal negative 5 plus 13, which is going to give me an answer of 8. And then this last one here, it says h of x equals x squared minus x minus 12, and I want to find the value of h of 3. So same thing, it doesn't matter that there's more than one of the same variable in there, as long as it's the same variable, at least for now. Okay. So h of 3 equals 3 squared, so anywhere I see an x, I'm plugging a 3 in, minus x, which is minus 3, minus 12. So that gives me 9 minus 3, which is 6, minus 12. So that's going to give me an answer of negative 6. Okay, so the next thing we need to review is domain and range. So in the function n equals p of m, the blank is all possible values of m. So our m is here, it's our independent variable. And our independent variable is always on the x-axis, and our dependent variable is always on the y-axis. So what's in the parentheses is m. It goes where our independent variable goes, which is on the x-axis, and x is always domain. And if you have a trouble remembering that, remember that D and X both come first in the alphabet, because then we have the range, which is all possible values of n, or our independent variable, okay, usually y. Okay, so all of these right here, it doesn't matter that these are different letters. We can graph these. Okay, we just have to know that whatever's in here is always the independent. It always goes with the x. And whatever's here is always the dependent. It always goes with the y, okay, the vertical axis. So let's take a look and do some domains and ranges. Some of these, this first one, we're not going to need our calculators, but we are going to need our calculators in a minute. So this one says the table below shows a dog's age at various points throughout its life in both human years, which is the independent variable. So human years is our x, and dog years, which is the dependent variable. So that's our y. First, it wants to know what's the domain of the function. So if I'm looking at just this, I see that there's some coordinates here. So an x and a y, an x and a y, an x and a y. Okay, I'm not given the bits and pieces in between each of these. We could probably figure it out. It's probably going to be a pretty straight, curve upwards. It doesn't go from 1 to -1, okay, because it's years, so it's going to progress. Okay, so that's going to progress pretty steadily. This might change just a little bit, though. I don't know. We don't know based on this information. So this right here is not continuous. In other words, if we were to graph this thing, continuous, there we go. If we were to graph this, we could not connect these points. So then our domain and our range are going to be written as a set, okay? So this notation here means set, okay? So it's going to be the set of the numbers 1, 2, 3, 4, 5, 6, and 7. Okay, so our domain is the set of those numbers, okay, the x, or the independent variable, and our range is going to be the set of our y values. Now remember, this is because we don't know 100% what's happening between these values. Okay, if we were given a curve or an equation, like a graph or an equation, then we could figure it out, but not with just points, okay? So if you see something like this, or you see a graph with just points on it with no line connecting them, you're gonna have to write your domain and range as a set. Okay, but we also have domain and ranges of functions. So these right here, we're gonna need to use our calculator to find. So I'm going to go to my y equals. So when you start your calculator, you probably end up here. The very first thing is click this mode button, and you want to make sure that you're in degrees. Okay, so scroll down, make sure that that radian isn't highlighted. If it is, scroll over to degrees, okay, and then hit your enter key. Okay. All right. So second, quit. So you see this blue key, it goes with all of these blue words, and this green key goes with all of these green letters for the most part. Okay. All right, so we're going to go to y equals. That's how we're going to graph this. It's very important that you remember your parentheses. So I have to put parentheses around 13 minus x. Otherwise, it's going to do 1 divided by 13 and then subtract x, okay, which looks totally different than this graph. So you have to make sure your parentheses are in the correct spot. And the other thing to remember, do not mix up the negative symbol with the minus symbol. Okay, this one's a negative for a negative number. This one's minus for subtraction. Your calculator will give you an error if you mix those up. Okay, so now that I've got this, I'm going to graph it. Okay, so I can see a little bit of my graph. Okay, if you can't see your graph, you can go to Zoom, and you can go to Zoom out. Okay. And I'm just going to do that so that I can show you how to get a better graph. So I can see my graph here, but I'm pretty far away right now. You see how there's all lines right there? So I can't see my individual numbers. So I want to get some better numbers. So I'm going to go to Zoom. I'm going to go to Zoom in, hit enter. And then I'm going to take this little arrow key and I'm going to scroll over. You can see my little scroller. I'm going to scroll over until I'm right there on those graphs. And then I'm going to hit enter again. Okay. And it's going to give me a graph so that I can look at it. This also is going to change my table so that my table is easier to see. Okay, because here I still can't really see what's going on. So I'm going to go second graph and that'll open my table. Okay, well I know that I'm somewhere in the positive numbers, okay, where my graph has something going on with it. And you can see right there at 13 there's an error. Okay, so let's go on ahead, let's go back to our graph and let's go back to our graph and let's get our domain. So with our domain, we're always going to go from left to right, okay, or least to greatest. Okay. With our range, it's always going to be bottom to top. Okay, always. Okay, so for the left, so this graph right here goes to the left and you can see it kind of stops right there. Well, it doesn't really stop. And if you go to your table, okay, and you go to some negative number here, you'll see that it just keeps going. Okay, we just can't see it on the graph because it's very close to the zero. Okay, so this is going to go in our x direction to negative infinity. I'm going to use a parenthesis because that means it does not include negative infinity. We cannot ever include the number infinity because we don't know what it is. Okay, but then our graph goes all the way to the right, but we have to remember that there was that little part that said error there. Okay, in our table. So see that at 13 there's an error. That means that there's a break in the graph. So it does not touch the number 13 and it does not include it. How do I know that? Because it says error there. There would be a number there if it touched it somehow but did not, but then didn't go past it. But then if we continue going up, we see that it gets some numbers again. Okay? So now we can say, or this thing starts at 13 and continues on to the right for infinity. And if you look at the graph, you can see that. So it starts again here at 13 and it goes to the right and it gets closer and closer and closer to that zero sign. Okay, so we're going to have to use our tools. We're going to have to use our calculator. All right, so I'm going to go on back to my y equals and I'm going to enter my second function. Okay, so now it says the square root. So I need this square root key here, if you guys can see it. See, it's in blue, so I'm going to push the blue key to get my square root symbol. I suppose I should clear my calculator out first. So hit my blue key, my square root symbol, and then it's going to be 9 plus x. Okay? All of that's under the radical. Some of you, your calculators will put it under, and to get out from it, you'll have to push the arrow. Some of you have to use parentheses, depending on your calculator. Now I'm going to graph it. Okay, well, I can see part of the graph, but not all of it. So I'm going to go on ahead. In this case, I'm going to start by going to Zoom Standard. And that's my favorite place to start because a lot of times you can see enough of the graph. So here you can see, we can see where this graph starts, hopefully. That looks like where it starts, but I'm not real sure. So we're going to go second graph to open our table. See, it's in blue. Okay. And it looked like it was going to negative x values. So let's go to the negative x values and see how far it goes. Oh, look at that. After 9, it started going to an error. Okay. And if we went to smaller increments in here, we would probably see that it would go to an error, because here, if I were to plug any number bigger than 9 in here, so even minus 9.1, I would get a negative 0.1 and the square root of that. I can't take a square root of a negative number. That's why it's an error. So my graph starts at the number 9 on the left. It does include it, and it goes on to infinity on the right. Okay, there's no breaks in this graph, so I don't have to do two different ones like I did up here. I just have to do the one. And this is called interval notation. Okay, so our next one is going to be 1 over 2x plus 1. So I'm going to do the same thing. I'm going to clear this out. 1 divided by parentheses, so that the 2x plus 1 is all together. And then I'm going to graph it. Okay, so we can see there something's happening. Okay, well, if I go to my table right now and look at it, you can see that these numbers are really small. They're changing really small. So 0.07, then 0.09, then 0.1, then 0.2, okay? But then, oh, look at that. Did you see that big jump between -1 and 0? It went a whole 2 points almost. There was a big jump there. So that means something happened between there, and we need to figure out what that is. So in order to figure out what that is, we are going to type in second. So we're going to hit that blue key, and we're going to hit the window key. Okay, so second window, that's going to bring us to our table setup. Well, we know that the change was somewhere between -1 and 0. So I'm going to start where it says table start. I'm going to enter -1. Make sure you use that negative key, not the minus key. So I'm putting -1. And then this right here where it says delta table, that's the change. So right now it's going in increments of 1. So it's counting 1, then 2, then 3. Well, the change happened between -1 and 0, so I probably want to make it some sort of decimal. I would start with something like quarters. So I'm going to put 2.25 there. So it's going to start at -1, then it'll be -0.75, then -0.5. Okay, so -0.25. And you could try quarters. You could try, sometimes you might have to do 0.1. Okay, but this one works really nice if you do this. So now you didn't have to push graph. I did. You could just hit second and table again. And now let's go on ahead and see what happens. Okay, so as our x value increases, okay, what happens there to that y value? Well, I get an error at -0.5. Okay, so that means that somewhere on here, I'm going to have a break at -0.5 where this graph is going to start and stop. Okay, so let's go on ahead and look at the graph. Okay, so on the left here, it's going on forever. Remember, it doesn't look like it is, but it really is. It's going on forever in the negative direction. Okay, and then it hits -0.5. So it goes from -infinity to -0.5. But then this other graph picks up at -0.5, but it doesn't include it. That's why there was an error. And it goes on forever to the right. So it goes on to positive infinity. Okay, we have a couple more of these to do. Okay. All right, so this next one is going to be y equals x squared minus 7. Might want to pause the video here and see if you can do this yourself. These are ranges though, so why don't you just do the first one with me, and then let's see if you can do them by yourself. All right, so I graphed this. Okay, it's the shape of a U. It's called a parabola, if you guys have forgotten. And we want the range. So with range, remember, we always start at the bottom and go to the top. So looking at this graph, how far down does it go? Well, if you're unsure, hit second graph and open your table up. And we can see how far down it goes. Well, at 0, it's at -7. And look, on either side of 0, it starts going back up again. It's negative 6.93. So the very lowest this thing is going to be is negative 7. And it does touch negative 7. So we put a bracket. Okay, this is a parabola. So if I go and see how high this thing gets, okay, my y values, how high do my y values go? Well, they're going to keep going. Okay, and if you look at the graph, just because my graph stops doesn't mean that my shape on my graph stops. Okay, so this one right here, a parabola, if your graph stops and that's where the shape stops, it probably continues to go on forever. So this is going to go on up to infinity. Okay, our next one, y equals, or sorry, g of x, which really is y, equals the square root of x. So the square root of x. Okay, well now I have to close my parentheses. Some of you will have to use this arrow key to get out from under that square root symbol, plus 5, okay, because it'll look completely different if you do it one way versus another. Okay, so here's our graph. We're looking at our y values now, our range. We're looking at the very bottom this thing goes and how high it goes. So if I go to my table, I can see that it's getting, so I'm looking for my lowest y value. So that's why I'm scrolling down here, because you can see that it starts at 7.5 and this is 7.1. So I'm scrolling down until I get to my lowest y value I can find here. Okay. Oh, look at that. Okay, so after 5, there's an error. So 5 is going to be my lowest y value. Okay, and my highest y value that I can get, well, it looks to me like it's going to go on forever. And once again, if you look at that graph, it stopped and it was getting higher. Okay, but it just stopped because we don't have any more room on our screen. So it's going to go to infinity. Okay, and now we're going to graph our last one. So 3x squared plus 1. Okay. So the squared key, you can either hit the squared key, or if you have something like to the 3rd or 4th up there, you're going to use this caret key for most of you, okay? And it'll either put a box up there or it'll allow you to put a number, okay? Okay, so let's go ahead and graph this. Oh, look, it looks like another one of those U-shaped things, another parabola. Okay, so let's go to our table and let's see what our very lowest y value is. And I'm going to change my table to go back to increments of 1, because otherwise it is going to take me a little while to get there. Looks like it might take me a little while to get there anyways. Here, you know what? I'm going to zoom, and I'm going to zoom standard. And then I will check my table start. So I'm going to start my table at -10, and I'm just going to go in increments of 1. Okay. All right, so now I should be able to get there. Oh, so there we go. So at y equals 1 was its lowest point, and then you see it started going back up again. Okay, so it includes that number 1, and it goes on to infinity, and you'll learn that about parabolas, that's what they do. They either go up forever, they go down forever. Okay, so let's look at these last 2 graphs today. So we want our domain on this graph. So remember, so this one's coming this way and it's going, and it looks like it's coming out really slowly. Okay, but it's still going to continue coming out forever and ever and ever. Okay, so this one is going to continue moving in that direction, just really, really slowly. Okay, so that is going to go from negative infinity on the left. And how far does it go to the right? Positive infinity. And now let's look at our range. So this graph, it doesn't stop. Okay, the function continues to go on forever, even though we ran out of graph right there. So that's going to be negative infinity. So we always start from the bottom and we go to the top. So same thing as with our domain, this one's going to continue to go up and up and up a little bitty bit at a time. So it's going to go to positive infinity. Okay, and this last one right here, I had said that those U-shapes can either go up or down. Well, this one's going down. So my domain, how far this way does it go and how far that way does it go? Well, it's going to continue going that way to the left a little bitty bit at a time forever. And it's going to continue going right a little bitty bit at a time forever. So our domain on this one is going to be negative infinity to infinity. But now we have to look at our range. So we can see here that it stops, and it stops at 3. Almost every time I ask this question in class, someone says it goes from 3 to something. It starts at 3, but that is not the case. Remember, we always start at the bottom. So how far down does this thing go? It goes forever in the downward direction. So it starts at negative infinity. Where does it stop? Its highest point is here at 3, and it does touch it. All right, so you guys have an activity or a worksheet or some sort of problems to do on domain and range today. Thank you for watching this, and I'll see you next time.